Hello guys, welcome to this video. In this video, I'll be discussing a question which I have touched upon and maybe discussed in many of my previous writings and even maybe videos. I don't remember exactly. And this question, I've talked a lot about this actually, and it's not anything new. But I'd like to discuss a different, maybe a different perspective because it's this particular perspective. I feel, as far as I remember, I have not discussed in any previous videos. It's quite recent. You can say realization of mine. Maybe not a realization, but whatever. So basically, if you know, I'll be sharing the link with you in the description. There is an article I wrote for in the Journal of Young Physicists a long time back. It's a kind of blog article titled "Did Einstein Believe in God?" A good article. I mean, just a blog article, nothing technical. In the article, I just shared my personal views on whether Einstein actually believed in God. Of course, I did not know Einstein personally. I am not his biographer. I didn't even study his character in detail. I just know his theories because I'm a physics student, but I don't know him as a person. I didn't even study him as a person. So of course I cannot you know claim to have a definite answer to the question, did Einstein believe in God? But I just feel like from whatever I know of him, and he made some comments about some seemingly ambiguous comments about God and all. I don't know whether all of them actually Einstein can actually be attributed to Einstein, but he definitely said some things from reliable sources about God and all. So what I felt like, I just shared my personal views on the article. I'm not saying they're correct, and I'm not forcing anyone to. Well, I shared that Einstein didn't exactly believe in God, especially if you by God if you mean some particular religious God or some supernatural deity, or any God who interferes in human affairs. Not that kind of God. Einstein believed in an uninterfering God. What I mean by an uninterfering God is that this kind of God, he just see, this is just a trick of the language, but just to put it in simple words, this God, which this uninterfering God, he created the universe, and he defined the laws according to which the universe would evolve, would function, and he just set the universe in motion and just let it evolve. He is not interested in human affairs. He doesn't interfere in humans. So basically, this is not a god at all in the usual sense of the word. Einstein just, whenever Einstein made these kind of comments, what I feel like, what I think, of course, like again I'm saying I did not know Einstein personally, but what I think is that what he meant was that he was referring to this kind of God. He just referred to this kind of God as the laws of physics. There is a famous saying, right? What one man calls God, another calls the laws of physics. So basically, why the term God? Why then at all introduce the term God? Because if you think deeply about it, you will realize, and maybe Einstein also realized, there are some questions, some deep questions about the universe, about the origins of the universe that science cannot answer, science cannot reach. It's not that science cannot answer today. Maybe science will be able to answer one in the future, but it's likely that science will never be able to answer these questions because these questions are unknowable, not unknown. They are unknowable. But like deep questions, for instance, why did the universe emerge? Yeah, maybe science can answer because of some quantum fluctuations, because of this, that. But why then? But if you go deeper, why quantum fluctuation works? Why not something else? Why? I mean, if you try to go down the rabbit hole, you will find that there are some. I mean, there's a limit to science. After a point, even science will not be able to answer the question definitely. If I ask you question about the immediate region, science will give you a definite answer. What is the acceleration to gravity on Earth? It is 9.8 meter per second square. Science will not tell you it's likely that it's 9.8 meter per second square, but it can be maybe 19 meter per second square. No, on Earth it is 9.8. We know that. The little variation that is due to experimental error, but theoretically the value is 9.8, nothing else. But but at this kind of fundamental level, science will not be able to give you a definite answer, any definitive answer. And it's not because that we don't know today, but if we research, maybe we'll be able to find an answer. Not that we will never be able to find an answer, because this cannot be grasped by mathematics or by logical reasoning. It's beyond science. At least it is likely that it's beyond science. For now it seems that it's beyond science. It's a high possibility. But as a physicist, what Einstein, it of course it's likely that Einstein must have thought about these questions at some point of time or another. He used to ponder these questions maybe once a week, twice a week, or maybe even daily, because he's a physicist. He was curious about the universe. So even he realized that maybe physics will not be able to give me answer to this. But he sometimes this question might come in his mind. So what he did was that his approach, his strategy, what I think, again, it's my personal view. He just assumed that, okay, let me just define this term God, God, By God, I mean an uninterfering God who created the universe. Maybe he was not referring to any conscious God. Just the universe came into existence and evolving according to some definite laws. So this order he calls God. This order, this predictability, this definite laws that the universe follows. So that, like, he was always against. I mean, he always believed in an ordered universe, a deterministic universe. Einstein was like, God does not play dice with the world. So I think by God he was referring to this, right? Not any particular conscious God or something. And he just used the term God because whenever these questions came to his mind, what will he do? Each and every time these questions came to his mind, will he again like explain all this thing to himself that okay, maybe physics will not be able to give the answer, maybe something happened. So just really call it God, a single word God. Okay, God created the universe. End of story. Now that doesn't mean Einstein was not inquisitive, but he realized that if he spent too much time on this, then it is not physics, it is metaphysics. It is then he would not be able to make some definite progress in physics. He would not be able to come up with some mathematical theory. General relativity would not have been possible. During his last 30 years, last 3 decades, Einstein focused on unifying electromagnetism with gravity. So that was a mathematical exercise, mathematical research. So, and that was something definite, right? He couldn't come up with the theory of everything, of course. Because, plus, he didn't take the nuclear forces into account as well. He didn't accept quantum mechanics and all. But at least he was doing physics. Now, if he actually went down this rabbit hole and got too much caught up in these questions, these fundamental questions, he would maybe have written a philosophical essay. Nothing more. He would maybe have written some good philosophical essays. Nothing more. He would not be able to make some definite contribution to the field of science, to the field of physics. And it's important. Right now, we need to understand the immediate world. We need to understand the mathematical theory. Then maybe in the future, we can see whether physics can answer the questions. But right now, if you focus too much on these questions and you don't do the actual physics, that is not a good strategy for a physicist. So that is why Einstein just did this. He just kind of swept this under the rug by using the term God and focused on physics. So this is what I shared, but I got a lot of comments in that article which I published. The article I was talking about, Did Einstein Believe in God? Journal of Young Physicists. It's in fact the article. It's more than 6,000, 7,000 views, which when you see the other articles, it's a huge. And I don't know how what instigated this or what initiated this, but a lot of people are commenting. Most of them negative comments, but most of these people are commenting with all due respect. They have missed the point of the article. They are most of the people, some of them at least. By reading their comments, I don't mean to insult or offend them, but by reading their comments, I feel like they don't have any understanding of science or physics. I mean, at a basic level, I don't expect them to have a technical understanding of physics because obviously, Journal of Young Physicists is for popularizing physics. It's not, the articles are not meant for experts in the field of physics. But most of the comments, they are commenting about religion, about Christianity, Jesus, and all this. I don't care because I see. I'm born an Indian and Hindu, but I don't. Whenever people ask me what is your religion, I never say Hindu. I never say Christian. I don't say anything because my religion is science. I don't want to relate myself with some particular religion. I was born Hindu, but I don't want to relate myself to be in that or to any religion because that means I'm introducing some bias in my thinking, which is very bad for someone who wants to do research in science, in physics, especially in fundamental physics. Because this is where this bias actually can affect your decision making. They will not be of much effect in experimental physics or much less fundamental sciences, maybe in medicine and all. But in this field, you have to be very careful about the psychological biases. So I don't know if I'm sorry if I offend any other people from any other Hindu people or my ancestors, whatever. I don't care. But in my life, apart from my parents, physics is the most important thing. I don't care about anything else. So that the point of the article was not. I was not trying to. I was not even writing about any religious god. It was mentioned clearly in the article. But so anyway, I got a lot of comments. I thought I would make a video about it. So if you ask me now, that article, I wrote the article many years back, like almost 3 or 4 years back. I don't remember the exact date. Almost nearly 4 years back, maybe in 2020, almost 4 years, 4 years back, 3.5 or 4 years back, 4 years back. I don't know. It's a kind of whenever I say 4 year, I hear Fourier. Really, recently, Fourier transform. It's a very important tool in physics. Fourier transform. It's the most important integral transform and in Fourier series and all these things. Anyway, that was totally irrelevant. I'm sorry about this. I don't know why I even said that. But anyway, so coming back to the point. So if you ask me today, do I believe in God? If you would have asked this question to me, say a few months ago, 1 year back, I would have said no or whatever. But now my answer is that this question which you're asking, this question is not a meaningful question in the first place because it is not the job of science. It is not the job of physics to answer these kind of questions. because this question cannot be analyzed scientifically. It is because see how will you analyze the question scientifically? You do not have enough statistical data, you do not have enough theoretical data. How can you scientifically answer the question? And if I so since it's not possible to answer the question scientifically, it is best not to answer the question. So right now, if you ask me, do you believe in God? I would say no, I don't. And if you insist me, then my personal views would be that for the most part, no, I don't believe in God. Especially if you are of course, I don't believe in religious God. That I can say with 100% certainty. And even if you're talking about an uninterfering God, even then I would say I don't believe in God personally, because see, it does not matter whether I believe or I don't believe. The strategy, I feel like the strategy should be, we should try to explain the universe, explain every aspect of the universe scientifically. I mean, maybe if you can find a theory of everything, which is, and if you can also prove that the set of laws that the universe follows, they are inevitable, then there is no need for God. If I can scientifically, now this is a very big dream. Maybe it's not possible, but maybe it will never be possible. But we need to try. And once we have tried for many years and we are sure, see, either we have to prove it is possible, or at least we have to mathematically prove that it's not possible. I mean, not just come up with one or two counter examples. You have to mathematically prove, rigorously prove in a rigorous manner. So if we can prove it's not possible, then okay, then I will believe in God. Believe in God in the sense, then I will accept that it is not possible. Science cannot answer this question, so let us just assign this term God to this. That is all. That is what I mean by believe in God. I'm not referring to any religious God. I will never ever believe in any religious God. But by this uninterfering God, I'm talking about this. But if we, on the other hand, if we can find such a theory, a physics theory, mathematics theory, a mathematical theory of physics, that's what I meant, that can not only explain all the aspects of the universe at all scales, but that can also explain, I mean, mathematically, that can rigorously explain why the universe follows this particular set of laws and not any other set of laws, then we don't have any need for God. Then there is no question that remains unanswered. Personally, I think we will never be able to answer all the question. Such a theory will always be a dream. A unified field theory of everything will maybe possible. But I don't think such a theory will actually be able to answer the question that why the universe follows this particular set of laws and not that. Actually, you see, it's not correct to say the universe follows the laws of physics. The universe doesn't follow the laws of physics. The universe just evolves spontaneously. All we can say, I mean, what we should say is that the universe behaves in a, at least we have not seen the entire universe. We don't know what is beyond the visible universe. Even we don't know much about the visible universe. But so far what our experience and what our knowledge, what our observation and experiments and theories in science tell us, the universe, at least the immediate universe around us, exhibits a great degree of predictability. Not, it's not entirely predictable. There are a lot of things which are unpredictable yet, and maybe they are inherently unpredictable. There will never be any definite laws of science or physics that will explain them. But the universe does seem to exhibit a predictability to a remarkable degree, at least the immediate universe. By that, in simple terms, what I'm trying to say is that the universe is predictable. We can formulate laws because some things repeat. The earth goes around the sun and it spins. If I throw a ball up, it will always fall down, at least in the earth. I mean, these things are predictable, they don't change, right? Of course, there can be slight variations, but we have not observed any significant variation as of now. So right now we can make a reasonable assumption, hypothesis. We can take it as a working hypothesis that the universe is predictable to some degree, to a great degree. In fact, not to 100%, not 100%, but to a great extent, to a great degree. And because the universe is predictable, we can formulate laws. Since because see, we are seeing that these things repeat. No matter how many times we carry out this experiment, no matter where we carry out this experiment, it happens. This is basically what we mean by time symmetry and space symmetry in space. It doesn't matter if I throw an apple, it will always come down. No matter whether I do the experiment in West Bengal or in Gujarat or maybe even outside India, or maybe if I do it today or tomorrow or day after tomorrow, whatever. So this is how this symmetry and conservation laws, Noether's theorem. Anyway, that's another topic. But the thing is that, so since the universe is predictable to some degree, we can make laws to make the study of the universe easier. Okay, this thing repeats, so that means let us define a law that let us try a few more experiments. Okay, so everything falls down, let's define a law of gravitation. Everything attracts. To make it more general, it's not just about falling down to the earth, it's if any two body with mass attracts each other. Just an example. So all the laws of physics. So see, that does not mean the universe follows the law of gravitation. The apple doesn't fall down because Newton's law is telling the apple to fall down. No, you should fall down. I am telling you, I am Newton's law. No. That is how the universe works. Spontaneously, it falls down. The Newton's law or law of gravitation or any theory in physics for that matter they just do a good job of modeling the behavior of the universe. Universe of gravitation, if we apply the law, we can predict the behavior of the apple or any falling mass, a macroscopic object. So that means the Newton's law, it does a good modeling of the actual scenario. But that doesn't mean the actual object in the universe is following Newton's laws. Newton's law is actually doing a good job of modeling that behavior and predicting that. That is why we take it as a valid law. But the universe doesn't follow Newton's law. The universe doesn't follow any laws of physics. So now the question is the question that we were discussing: why the universe follows this particular laws of physics? I mean, why is there any other universe which follows some entirely different law of physics? You could say yes, there is such a universe, but of course, if the fundamental constants were a bit different, then life could not have emerged. At least that is what our science current present knowledge tells us. So maybe there is such a universe, but there is no life in the universe. So we are not in that universe, so we cannot perceive it. Maybe such a universe exists in as a parallel universe. It is completely out of our reach. Again, parallel universe is something many people will say it is not a scientific idea. I get that point. You cannot experimentally verify. I mean, as of yet, we have no experimental methods to verify whether parallel universes exist or not. They are just a mathematical curiosity, a theoretical curiosity, theoretical possibility. But I feel like the idea of parallel universe is not entirely rubbish, because even if we cannot experimentally verify it, maybe we'll never be able to experimentally verify it ever. So it does not satisfy the condition of falsifiability. So from that sense, it's not a scientific idea maybe, but still, I think the idea has merits because it solves a lot of paradoxes in theoretical physics, plus even some theories in cosmology, inflation and all. They also predict the existence of parallel universes, and these theories have received some experimental support, not on the parallel universe aspect, but inflation theory we have some experimental support, right? If you study the early universe and all this, this observation, this cosmic microwave background, and all many things are there. So, and if you accept a theory, you have to accept all its predictions. You cannot like say, so let me accept this particular point of this theory, but let me just cut out the point and because the theory predicts the existence of parallel universes, so you have to accept that as well. Plus, I find the many worlds interpretation of quantum mechanics to be a very mathematically elegant interpretation, even if there is an experimental support. I mean, at least it's better than Copenhagen. It's better than a lot of other interpretations of quantum mechanics. Of course, some people will say there should be no interpretation of quantum mechanics because it's just mathematics. In some, yeah, there in after a point in theoretical physics, what my experience tells me is that you have to rely entirely on the mathematics. There may not always be a visual or a physical analog. For instance, in quantum mechanics, there is no analogy of spin. We can say the electron is spinning like just like this, but that's not actually incorrect. Spin is an inherent quantum mechanical property of the electron. If there is no classical analogy to spin, then maybe some transformations. If it's a simple transformation in 2 dimension, you can maybe visualize that on a graph. You can do some simulation, computer simulation. But suppose you have a transformation in 5 dimensions, in a 5 dimensional space, 4 dimensional space, then there is no way for you to visualize. You have to depend. The formula is the same. The mathematics is the same. You can use the same mathematics. You can modify your code, and your computer will give you the result. You can compute. You can get the result. You can get the answer. But you have to depend entirely on the mathematics. No physics after a certain point. So similarly here also, maybe there is no experimental evidence, but I uh, I find it a good example. Many words interpretation. I find it a good interpretation. See, the analogy I gave about mathematics and physics and this many worlds part, they're not entirely similar. I realized right now. So, but yeah, anyway, that was also an important point. So I just discussed it in the video, maybe whatever. So yeah, the thing is that so we don't know whether there is a parallel universe in which follows some other laws of physics than our present universe. But even if we ask you that why our universe follows this particular laws of physics, what will we answer? One possible answer is the other possible sets of laws of physics, they are followed by some in some parallel universes. That is one possible answer. But what else? You could say that our extreme hope would be that maybe one day in the future we will find a mathematically consistent theory that will explain why these laws are inevitable. That like maybe the universe had to follow these laws of physics, not just from the point of view because we exist, because life has emerged, but even from the point of view of physics. This is the only possible set of laws. If we can prove that, then that will also be a possible answer. But we have to prove it, or we have to prove that it's unprovable. Or then if all of these options fail, then you can say that God, it's God's wish. God set the constants in our universe. God just wanted. I mean, God was just playing with the laws, and God said that okay, let me try with these set of laws, and He just assigned this set of laws to our universe, and our universe is following the laws of physics. Seems like a very unscientific answer, but and yeah, we should resort to God only as our extreme last hope when we have exhausted all the other possibilities. But just saying this is a last possibility. But then then if I ask you, okay, so you're saying universe follows these laws, this set of laws because of God. Fine, very good. But then is God predictable or unpredictable? See, this is the paradox. If I say God is predictable, that means we can describe God by some laws as well. Then God is itself becoming part of these laws. So if I am part of the laws of, then how can I define the laws? It's not possible. But if God is defining these laws, that means God himself or her, I mean, whatever we usually define himself. So then God himself must be unpredictable. I mean, unpredictable because he should not develop, he should not exhibit any periodicity or any predictability, because then we can also bring him within the reach bound of some laws. Then he will not have that power of God. Then he will just be like another object in the universe which can be described by the laws. He will not have the power to define the laws of that the universe will follow. So then you're saying, okay, so then maybe God is unpredictable. But if God is unpredictable, then my question is why the universe has been following the same laws of physics. At least as far as the knowledge, we have not been able to see any huge discrepancy for the last 14 billion years. God is unpredictable, then why is he not playing around with laws? Why is he not changing? Why is he not destroying the universe? This is not a valid. This is a question. I mean, from this I cannot conclusively prove that God is not unpredictable. God is unpredictable does not mean he will always do unpredictable jobs. Maybe he is predictable for a second. 40 billion years to us is a second to him. Maybe the next moment, or maybe after 100 million years more, maybe he will do something unpredictable. I don't know whether humankind will survive that long or not. So anyway, so this is just some points which I wanted to discuss, and I encourage you to think about these points, but not get too caught up in these points, because again, there's a fine line between what physics can definitively give a definitive answer to and what science or physics cannot give a definitive answer to. So you should be careful not to go down the rabbit hole of metaphysics or philosophy. But still, at times it's useful to think about these questions just to get, because they give you a new energy. You are doing physics, like in my case also I am doing physics all the time, technical physics, mathematics and all. But sometimes it's refreshing to think about this. Just that don't get too caught up in this and forget to do the real physics. So anyway, I want to discuss these things in the video, and I'll share the link of my article in the description. Did Einstein believe in God? You can check the article and the comments as well. And I'll also share the link of one more article which I wrote for the Journal of Young Physicists about a few months back, almost 6, 7, 8 months back, a long time back. In that article, it's a kind of written in a kind of discussion interview style. I have answered a lot of questions about physics, technical questions, and even some not philosophical but some less technical questions as well. I mean, I've discussed all the important topics. I mean, most of the important topics in physics, from classical physics to relativity, cosmology, astrophysics, quantum physics, chaos theory, even modern physics, theoretical physics, and even some general questions about physics. So I think if you have not checked that article, you will find that article interesting. But yeah, that article is 100 minutes read. It's a pretty long article. So of course, very few people will have the patience to read the entire article. But you can just check it out. That's all. I'll drop the link of both of these articles in the description. That's all I wanted to share it with you in this video. Let me know what you think about these topics, whether you be a physicist, a philosopher, or just an ordinary person. I would like to know your views. Just feel free to comment below. And yeah, thank you very much.